Okay, so we have another OpAmp circuit here, and the question is to find gain. So we have two input voltages, V1 and V2, and so we can go ahead and apply our conditions once again. So the there's no current flowing through the OpAmps, and then the voltage over here, let me put Vn. The voltage over here is equal to the voltage at the positive leg, so Vn as in negative and Vp as in positive. Okay, so we have two nodes here and another one over here, so we can go ahead and assign currents. So let's call this one I1. Let's call this current, well, there's no current going through here, so of course there's only one current coming out of that node, so that will be, let's call that I2. And there's no current that will flow through the positive leg either, so if we call this I3, and then let's call this I4, you know, just to kind of see what's what basically. Okay, so now that we've done that, we have two nodes, so this is 1 and this is node 2. Okay, so now KCL at node 1, KCL at 1 gives us I1 is equal to I2, right? So we have I1 is equal to I2. Now what's I1? I1 is V1 minus Vn. We don't know what Vn is, so V1 minus Vn over R1. For now, let's not plug in values at all. Let's just use R1. Okay, maybe we'll see some cancellations later on, maybe. So V1 minus Vn over R1 is equal to I1, and I2 is current is flowing through this direction, so this is a higher potential, so Vn minus V0 over R2. Okay, so basically, okay, let's go back here. Gain is, what is gain? Gain is V0 over V1 minus V2. That's in the book. Basically V0 over V output, the voltage, output voltage over the input voltage, and or you can write it this way as well, V0 over V1 minus V2. Okay, so now there are a lot of unknowns here, and we know that let's do it this way. Okay, so Vn is equal to Vp, so there's another condition as well. So if Vn is equal to Vp, we can go ahead and find what Vp is. Obviously we can find Vn from this here, so we gotta find it from here. So Vn is equal to Vp, and Vp is basically the voltage across this particular resistor as well, right? Let me put plus minus there. Okay, that's the voltage across this resistor. So you can tell that this is a we can use voltage divider actually to find Vp. Okay, so Vp is the actual resistor, so R4 over the sum of the resistors, R3 plus R4 times the input voltage, the source voltage, which is here V2. Actually, this relationship, you can actually prove it by, oh, this is 4. Hold on. This is a 4 here. So, yeah. You can prove this relationship by using KCL, because there's no current that would flow through this. So I3 is equal to I4. Okay, let's just put it here. I just want to prove this real quick. So let's see here, I3, and then I will erase it. I3 is equal to I4. I just want to prove this real quick. So I3 is equal to I4, and I3 would be V2 minus VP, the potential difference, over R3, and this is equal to I4. I4 is VP minus 0, so VP over R4, right? Because here it's ground, so that's 0. So now to get VP, you would have let's see here, we have V2 R4 minus VP R4 is equal to VP R3. So minus VP R3, everything is equal to 0. So now if we take VP and we have well, let's put minus VP here, and we have R4 plus R3 is equal to minus V2 R4, and therefore VP with the minus signs, you obviously see that it's V2 R4 over R4 plus R3, and you rearrange it like this way and it's the same thing. So this is voltage divider proven from KCL. I just wanted to show you how I got that basically, but you can clearly see right away that you can use voltage divider to get this relationship over here. So let me delete this, erase. Okay, that was just a little note there. Okay, so back to our problem. So now that we get VP and we know that VP is equal to VN, the only relationship that we have here, we can put it back in there. So we can replace VP by its value here. Let's just by math, we can have this V1 over R1, just to simplify, minus VN over R1 is equal to VN over R2 minus V0 over R2. Okay, over R1 plus V0 over R2 is equal to Vn over R2 plus Vn over R1. So this is also equal to Vn R1 plus R2. Yeah, I think it's easier this way, over R1 times R2. Okay, so now we can go ahead and replace Vn. I wonder if it's actually easier, but let's see here. Okay, so now we have let me go back down a little bit more. So now I have V1. Okay, so what am I calculating again? Gain. Okay, okay, so I have V1 over R1 plus V0 over R2. This is equal to, we can replace this by its value, so we have R4 over R3 plus R4 v2, so we can put v2 over here actually. Now that's our vn. Now we can multiply by r1 plus r2 over r1 r2. Alright, so I have v1 r2 plus v0 r1 r2. This is equal to this is equal to r1 r4 v2 plus r2 r4 v2 over r1 r2 times r3 plus r4. So I can pretty much cancel r1 and r2's here, and I'm left with v1 r2 plus v0 r1. I'm sure there's easier way. I probably can't just see it, but after we set up our equation, you can use any method that you want to pretty much solve it, because it's just math from here. So v0 r1 is equal to v2 r1 r4 plus r2 r4, everything over r3 plus r4. R2 is 200, so I have 200 v1 plus 5 v0. Oh yeah, I can see it now. So v2, so now I have 200 v1 is equal to 200 v1 minus 200 v2 minus 200 v1. Okay, so now I have 5 v0 is equal to 200 v2 minus v1. Yeah, v2 minus v1. If we divide both sides by that, then this cancels out. So, and then you divide both sides by 5, so that's 40. Yes. So your gain is equal to 40. That's it. That's the answer right here.